Hello and welcome to lecture 6. In this lecture, we will see the important concept of multithreading as applied to concurrent assertions. We'll also see how formals and actuals work, and also disabling of assertions, how they work. Okay, let's start with multithreading. I will go back to my good old example of sequence, property, and how the property is asserted. Here's the clock. Here's the C start signal. Here's the request, and here's the grant signal. Let's say that at this passage of clock, C start is asserted. It is sampled high. As you know in this property, if C start is sampled high, the overlapping implication says that the request also must be sampled high at that clock edge. So we see that happening here, and 2 clocks later grant should be sampled high, and we see that happening here, and the assertion passes. Now let's see what happens. The very next clock edge, C start is sampled low, and since it is sampled low, this implication won't fire. This assert property won't fire because C start is not high. Okay, moving along. And I call the first as S1 thread. Now at this clock edge, C start is sampled high again. But before I show, as you can see the relationship here. But note, the very first thing you note here is that the first thread, S1, completes the same clock that the next thread starts. That is multithreading. It's not like because the first thread was ending here that it will ignore the second thread. So the second thread starts the same clock as the first thread completes, and it will go through this property and sequence exactly like the first one, and it will pass at this clock edge. Now, as 3 thread starts the very next clock, and at that clock the thread S2 was still executing. It has not ended yet. That being the case, S3 will still start, it won't be ignored, and it will go through its transitions. And in this particular example, I'm showing the transition such that all the 3 threads pass. So the point is, with concurrent assertions, you really don't need to worry about when the antecedent will fire, when a particular thread that started with the firing of the antecedent will complete, not complete, could be in the middle of the execution, and how the very second firing of the same property, same assertion, will affect the preceding assertion. You don't have to worry about any of those things. This is a very important concept that you need to understand. As you can see, there are more complications when we will see this bound 2 is called a delay operator, and we'll see what happens when you have range based delay operator. Then the multi-threading becomes even more complex, but let's keep that aside for now. Right now, just understand how the multi-threading works for non-range based clock delay operator. Now let's move on to formal arguments. You might be familiar with some of this from your regular Verilog knowledge or SystemVerilog knowledge. So here are the formal arguments. Sequence is the same property and sequence again. And you have A and B as the formal arguments. And you have formal arguments logic, PA and PB. And from this property, as you know, we call the sequence SR1, and we pass P and PB as actuals to the A and B formal. So these are the actuals, PA, PB, and request and grant. So when we call the property PR1, we pass request and grant, which gets these actuals gets assigned to the formal PA and PB. And the P and PB as actuals get assigned to the formals of the sequence. This should be straightforward. And if you do not declare a type for a formal, then it will take the type of the actual, which makes sense. So here's a practical real life application where basically you create sequences which are of quote unquote generic nature. And then you are a generic nature which are parameterized. And then you use the same sequence or the same property for that matter repeatedly with different assertions. So for example, I have this property called no change sig, which has three what I call parameters or formals: pclock, ref sig, and stable sig. What it says is at passage of clock, if ref sig is not asserted, that the stable sig should be stable. Now what I'm doing is I'm taking this property and asserting it here, assert property, no change sig, but I'm passing it sysclock, output enable, and read data. And so these three actuals will take place of these three formals. And whenever output enable is low, that means output is enabled, then read data should be stable. Now, without changing anything, I assert the same property, but with write enable. So it's a very simple concept which you may apply to your projects, where what you normally do is you create a library of quote unquote generic properties or sequences which has formals, and then you keep changing the actuals for the same sequence with different signals. Some more points on formals and actuals. You can have a default on a formal, and then you can connect quote unquote actuals with the formals using position based. This is very similar to Verilog. Or you can use name based connections to connect the formals and actuals. And this is the same example again. The points I'm making here is, since there is a default assigned to eneb E and B here, you can simply skip connecting that particular formal in this particular property, or if it's a position based connection, this is name based, this is position based, you can simply leave the position empty but followed by a comma and then request and grant. This no need to go into detail because this is very, very similar to what you are familiar with in Verilog. Here's a very powerful feature that I use a lot. So here's a property which has a formal called csig. You have enable and the same logic PA and PB. But see what I'm doing. I'm inside the property, I'm saying at csig. Whenever csig changes, pause or negate, eneb implies the consequent. The antecedent implies the consequent. I use csig formal into my sampling edge. Sampling edge being csig here. Then what I do here is I'm taking pause edge of clock. You can have an actual which is an event control. That's very powerful. You take the pause edge of clock and you pass it as an actual to csig. So now csig will be pause edge of clock. So at pause edge of clock, you do the rest of the assertion. And to pass an event control will make it very easy for you to create again a generic set of properties or sequences where you can even change the event control, the sampling edge directly from outside of the property and keep the property generic. Now this concept I'm laying out here, even though we have not used local variables, we do not know what a local variable is, at least up to this lecture. The point I'm making here is inside a property, you have a variable called LData, which is of size D size to 0. And what I'm saying is I'm passing the formal D size to size this variable LData. And then I'm passing tick D31 to size to declare this LData, which will be 31:0. But you cannot do this. You cannot use a formal to size a local variable in a property. The size can only be a constant or parameter constant because it needs to be known at the elaboration time. So this is a mistake people make when they are again trying to create a set of properties and sequences which are of generic nature. For example, in this case, the bus can be of different size, and you can pass different register sizes to size a register inside the property, but that is illegal. So be careful of it. Now let's see, so far I haven't shown you the disabling condition of an assertion. Now this is a sort of complex assertion, but we don't need to understand the complexity of it. The only thing we need to understand is that here's the antecedent $fell burst mode, which implies non-overlapping, that the data act will remain asserted within the SOE sequence. This sequence remains true within this sequence. Let's not worry about how within works, and let's not worry about any of the complexity of the property here. What is important is I'm saying that do not execute or do not even look at this incident if reset is active low and reset is low. Disable if and only if reset is low, do not execute this. If reset is not low, execute this. Let me show you what happens if reset is low. So here's the simulation log of this particular assertion. And very quickly, the reset remains high throughout the execution of this assertion. And obviously, I have designed it such that the assertion pdiff passes. I haven't shown the assert statement here, but the name of the assertion here is pdiff, and the property pdiff or the assertion pdiff passes. Now let's see what happens if the reset goes low. In this, on the right hand side of the log, you see the reset goes low during the execution. This is exactly the same from 20 to 120. During the execution of this logic, this properties, assertion goes low. Now, important thing to note here is it will discard this entire assertion if the reset goes low in the middle of the property. It's not that it discards and gives you a fail indication. It won't give you a fail indication. Obviously, it won't give you a pass indication. It will simply discard it. So be careful on when you, let's say reset is a very typical example. When you assert the reset, make sure you're not executing a property. I mean, you can, but then also know that if the last property which was executing during reset, you wouldn't know whether it passed or failed. So that's how the disable if works. Note that it always needs to be before the antecedent. This is our antecedent. You have to declare the property before it. You cannot declare it after it, or you cannot declare it in the consequent. And the disable if is only allowed in a property and it's not allowed in a sequence. Again, sequences are very generic, they are temporal domain, and they can have Boolean expressions. But that is one of the difference between property and sequence. You will see throughout this course the differences between sequences and properties. Like I showed you earlier, that if the property passes, you can have a display statement or whatever, a procedural block here for pass. Else, if it fails, you can have a fail action block. by default, it is considered a runtime error. This is the default according to the LRM. And you can, if you want to quit the simulation because this is a major assertion failure, then you have to use $fatal, just like shown here, else $fatal, and so on and so forth. If you don't say anything, you simply say else and semicolon, then it will by default use $error. So again, this is a short lecture, and we have gone through some of the basics of concurrent assertion. And I will thank you for attending the lecture, and I will see you soon in the next lecture.